Hi, so part of some research work I'm doing, I made these little demos, and it sort of illustrates the point quite well. So what's on there is the little chip is an ATtiny85, and what that little chap is doing is measuring its own voltage, and when the voltage exceeds a certain threshold, which in this case is 3.5, it will discharge the accumulated power from the supercapacitor. Should fire again in a minute, I think. And so what, you might say, is it going to fire? It should do in a second. There we go. So what's the big deal about that? Well, I've got a geared micro motor there, and that motor won't even consider starting till about 50 milliamps, maybe as much as 75 milliamps. But if you look on my power supply there, I've actually measured that at 5 microamps. So of course what's happening there is the energy is being accumulated slowly but surely, very low current, about 3 volts, 2.9 volts. And the microcontroller is alive all the way through that, so it's monitoring its own voltage. Now that's quite an unusual thing to do, because look, the only supply that's there is the supercapacitor, and that varies. That varies according to the accumulated charge on it. So the microcontroller is measuring that, and when it's happy that there's sufficient charge contained inside the supercapacitor, then it's ready to do some work, and that's basically what you see when that arm goes round. Now what's so clever about that? Well, without the strategy, without the controlling strategy, that motor can't do anything. It can't even run. So what we've got here is a kind of store and dump kind of thing, analogous to, I want a nice expensive sports car but I can't afford it, so I save up and then I go out and buy it. And obviously once I've bought it I can afford to fill it up with petrol once, and then I can't drive it anymore. No, only joking. But you get the idea. So save it up, dump it. Save it up, dump it. And that works really nicely. And that's part of some near-field comm stuff I'm doing, where we have passive active devices in near-field comms, but I just put this together as a little demo. Very, very simple piece of code on that ATtiny. Only really about 20 lines, something like that. Measure the supply voltage coming from the super cap. Make a decision. If the decision is to fire, then it's fine. Otherwise, go to sleep for 8 seconds and then wake up again and have another look at the supply voltage. So really, really simple, but really quite effective. I'll let it fire one more time, and then I'll say ta-ta. There we go. And obviously if I increase the current, it just becomes just like normal. So once you get to about 50-60 milliamps, actually I'll do that for you. So current, and up we go. There we go. So we're looking at 100 milliamps now. In a second that will catch up, and that will run pretty much continuously. There we go, look. So that microcontroller is no longer going to sleep, because it doesn't need to, because it can see there's sufficient power on the supercapacitor. And if I bring down the current, so here we go to 25 milliamps, sorry. You'll see that in a second that will catch up, and that will start to switch again. There we go, so it's realised that it's flattened the supercapacitor a bit. So now it's going to sleep for 8 seconds, and then it will wake up. There we go. And flatten the supercapacitor a bit, so sleep for 8 seconds. And off it goes again. Get the idea? Okay, bye for now.